Welcome to Mrs. O's Math World. Today we continue to discuss the property of reflectional and rotational symmetry. So these are the words that is uploaded by some of you. For the left hand side, you can see that all these are having reflectional symmetry, but not rotational symmetry. For this object, all these are having one axis of symmetry. And for the objects on the right hand side, so many of you say that these objects, windmill is the most popular, and these objects are also having rotational symmetry, but not reflectional symmetry. But some of you say that the square and the rectangle are with rotational symmetry but not reflectional symmetry. But they are incorrect. For the rectangle, you have axis of symmetry like this. That means you get two axes of symmetry. It is not correct. Okay, so this one not correct. So let's mark it. So for the long run, you also get 4 axes of symmetry, which is also a kind of reflectional symmetry. So these two are incorrect. So for the rest of them, they are correct, with the order of rotational symmetry as follows. So, what is Mrs. O's answer? It comes from the lin gao here. So let's see how it works. So we need these ingredients: lin gao, egg yolk, and it is for making the tart. So I put the lin gao on it and cut it. See how it works. So roll it up. In this way. That's it. And for the next part, we cut it. Cut along the line. And then we fold it. 1, 2, 3, and 4. We make it 4 times to make a windmill version. So after that, we make it together to cook, put them in the oven. So now you can see that there are 2 ways to make the dessert. Alright, okay, so for the right hand side, you see the windmill is having rotational symmetry with order 4. And for the left hand side, you see that there are some cakes, and we take one of them. So you see that this one approximately, right? So we have axis of symmetry in this way. But this one we don't have rotational symmetry, because when we rotate it, this part will not be the same. You see, this one go upwards, is different, but this part it goes downwards. So I hope you won't get too hungry at this moment. So at the beginning of this video, so we have discussed that this rectangle, we have both rotational symmetry and reflectional symmetry. So how to add this on this graph so that we won't have reflectional symmetry of this object? So the method is like this. So one of the methods is to cut two identical triangles and form the figure on the right. So you see, when I rotate it, the graph will repeat and repeat. But as you know, the triangle is not isosceles. That means when I cut it, then I can't see any way to make a reflectional symmetry of the object. So you may also try to make similar figure so that we get an object originally we get both reflectional and rotational symmetry, but after you make some minor change, then you can see this object can become not having a reflectional symmetry, but we still have rotational symmetry. Finally, let's look back on the Lingard. So what is the rotational symmetry and also the reflectional symmetry of Lingard? Well, whatever it moves, it will also have the aspect of symmetry, right? So it means we'll have lots of it, like this in this way, turning in another way, and so on. And for rotational symmetry, the center of rotation is here. Okay, so this is the center of rotation. Well, it's also very difficult to describe how many folds here are there for the order of symmetry. So usually we will say that there are infinitely many. So this special case is pretty interesting, right? So we have gone through many special cases in this session. So I hope you understand the features of reflectional symmetry and rotational symmetry. So that's the end of this episode's Math World. See you next time!